Hello, thank you for watching this video. So in this video I'll be doing question 10 of November 2022 question paper Physical Sciences paper 1, and this topic is the photoelectric effect. So I'm going to read the statement and then proceed to answer the questions that follow. So let's go. Light is incident on the cathode of a photoelectric cell connected to a battery and a sensitive ammeter as shown below. Light is incident on the cathode of a photoelectric cell connected to a battery and a sensitive ammeter as shown below. So light, here's a light incident on the cathode of this photoelectric cell. So let's answer the question that follows. What conclusive evidence about nature of light provided by photoelectric effect? 10.1. What conclusive evidence about the nature of light is provided by photoelectric effect? So the photoelectric effect, we know from waves that light behaves as a wave, but the photoelectric effect, it demonstrates the particle nature of light. So the photoelectric effect demonstrates the particle nature of light. So it's the particle nature. Particle nature of light. So that light contains some particles. So photoelectric effect, it tells us about the particle nature of light. So let's go. The cathode has a work function of 3.42 times 10 raised negative 19 joules. Question 10.2, define the term work function. What is a work function? So a work function, it is the minimum energy the incident photon should carry in order to emit or eject electrons from a metal surface. That's what it is. So it is the minimum energy the photons of the incident light should carry that they need to carry to be able to knock off electrons from a metal surface. So you know a photoelectric effect that in photoelectric effect you observe it occurs when an incident light is shown into metal and electrons are emitted from that metal. So, but in order for those electrons to be emitted or ejected from a metal surface, the photons of the incident light should contain enough energy to be able to knock off those electrons or free those electrons from a metal surface. So, in this case, so now the work function, it is that minimum energy that those photons should have in order to be able to emit electrons from a metal surface. That's what the work function is. So, I'm not going to write it down, but it is that. It is the minimum energy the photons of the incident light should have or are required to have in order to emit or eject or free or liberate electrons from a metal surface. That's what it is. And then let's continue. So 10.3, calculate light of frequency of 5.96 is shown onto the cathode. Then let's go. 10.3. Calculate the maximum kinetic energy of an electron ejected from the cathode. So you are given the frequency of a light that is shown onto the cathode, and you are given the work function of a cathode. So now they want you to calculate the maximum kinetic energy of the ejected electrons. So now, which means the energy of the incident light is equal to work function plus your maximum kinetic energy. So you know the energy of a light is h times frequency, which is the Planck's constant, times the given frequency of a light, which is equal to work function, which we are given. We're given that the work function is 3.42 times 10 to the minus 19, right? Plus EK max, which is the maximum kinetic energy. So H is Planck's constant, which is 6.63 times 10 to the minus 31, I think. Let me double check. Ah, 34 times frequency of the light, which is 5.96 times 10 raised 14 is equal to, looks like we'll need some of this. Your work function, you are given that the work function is 3.42 times 10 to the power of minus 19 joules plus your maximum kinetic energy. So you just solve for this. Then transpose this to the side and punch this in the calculator. So you'll have the answer of this minus that. So first thing we do, we punch this on our calculator. So 6.63 times 10, 6.63 times 10 raised negative 34 times 5.96 times 10 to the power 14. So what we have 3.95 times 10 to the power minus 19. Then you transpose this to the side, minus 3.42 times 10 to the minus 19 is equal to your maximum kinetic energy. Right? Then just find the difference between the two. 3.95 minus 3.42 times 10 to the minus 19. You have 5.31 times 10 to the joules. This will be your maximum kinetic energy. We're done with this one. Then let's go. This is a 10.3. This one. So let's go 10.4. So the ammeter registered a constant current of 0.012 M. Calculate the minimum number of photons of light that strike the cathode in a 10-second period. So you are given that your ammeter of this cathode, which is our ammeter, registered a current of 0.012 amps. So now they want us to calculate the minimum number of photons that strike the cathode in a 10-second period. So now, what you need to understand here is, if you are told that you have this current, right, and they want the number of photons that strike the cathode, in order to be able to find how many electrons or photons have struck the cathode, we must calculate what is the number of ejected electrons on that 10-second period. Once you have the number of ejected electrons on that 10-second period, then you will have the number of photons then you will have the number of photons that struck this cathode of ours on that 10-second period, because each photon knock out one electron, because we said the work function is the minimum energy each incident photon should have in order to emit or liberate electrons from a metal surface, right? So now, if you're able to calculate how many electrons were ejected on a 10-second period, then each electron represents each photon, because each photon that comes from the incident light is responsible for liberating or releasing the electron from a metal. So that's what we need to do. We need to find how many electrons were emitted on that 10-second period. Then now, the same number of electrons will be representing the same number of photons. That's what we need to do. So, we're given this current. What is current? Current is the rate of flow of charges. So, current is the rate of flow of charges, right? So, which means we have current, we have period, which is that 10 seconds. We can find the charges, the flowing charges, or the amount of charge. So we say current 0.012 is called Q over T, which is 10 seconds. So this times that, have 0.12 is called column, is called our charge. 0.12 column. This is our charge. So we have our charge to be this. Now we must find the number of electrons. So the number of electrons is equal to our charge, right? Which is that divided by our electron charge. So this will be equal to 0.12 coulombs over 1.6 times 10 to the minus 19. I think that should be an electron charge. Yeah. So the number of electrons is equal to, then punch this in the calculator. Your answer would be the number of electrons, which should be the same as the number of photons, because each photon is responsible for knocking out each electron. So if you find that this number of electrons, then you have your number of photons. They are the same. So 0.12 over 1.6 times 10 raised negative 19. So you have 7.5 times 10 to the 17 electrons, right? This is the number of electrons emitted. Therefore, this number of electrons is released or liberated by the same number of photons. Therefore, 7.5 times 10 to the 19 photons. 17 photons stroke the cathode. In a 10-second period. This is it. Then, let's go. 10.5. The intensity of the incident light is now increased, which is the intensity, which means now, when you increase the intensity of the incident light, which means now you have more photons. You have more, you increase the number of photons now that are striking our cathode, which is more electrons will be emitted, which means now more electrons will be flowing here, which will have higher restriction of the ammeter. Let's go. The intensity of the incident light is now increased. How will this affect the ammeter reading? So the ammeter reading will increase, right? Because what will happen, if you increase the intensity of the incident light, then now you have more electrons, or you have more photons striking your cathode, which means more electrons will be liberated from the metal, and you have more charge flowing, right? So we have more charge flowing, that means higher current. That's what this is. I don't think I need to write this down, because I just explained it, and I'm done.